incredible advancements revealed. The United States has unveiled groundbreaking details about its next-generation aircraft, showcasing technology that redefines modern aviation. These advanced machines boast unmatched stealth, advanced AI systems, and hypersonic speeds. How will these capabilities change air combat and dominate the skies? What are the challenges these aircraft are currently experiencing? Join us as we reveal interesting details concerning the U.S. new technologically advanced fighter jets. The common knowledge of the U.S. Air Force's NGAD is that it is a program designed to create a sixth-generation fighter to replace the F-22 Raptor and to create a highly advanced air superiority aircraft capable of dominating even the toughest battlefields. However, much more is unknown and kept out of the public eye. At its core, the program focuses on developing a manned sixth-generation fighter with advanced technology to counter threats from advanced adversaries. It boasts of advanced stealth technology that allows it to operate seamlessly even in highly contested environments, where it can easily evade detection by radar. Its superior stealth capabilities are achieved through advanced materials and design techniques that make detecting aircraft challenging for radar systems. This technology enables the fighter jet to undertake critical missions that would have been impossible with conventional aircraft. Furthermore, the fighter's survivability is enhanced by its ability to operate in high-threat environments, making it an invaluable asset on the battlefield. One of the key advantages of these aircraft is their exceptional speed and agility. With the ability to reach impressive speeds, they can maneuver quickly and easily perform evasive actions. This provides a significant edge in evading threats and executing tactical maneuvers in combat scenarios. Speed and agility make these aircraft highly effective in various contexts, from air-to-air combat to reconnaissance missions. However, this program has come to a standstill due to the rising costs. The cost, projected to be hundreds of millions per aircraft, combined with the rapid growth of autonomous technologies, have prompted the Air Force to reconsider its strategy. This pause allows for a careful evaluation and review of whether a mix of manned and unmanned systems might offer a more effective and affordable solution for future air dominance. The review aims to take a fresh look at the needs for the sixth-generation fighter and decide if the current plan matches the changing threats and budget challenges. The outcome could change the program's direction, moving away from a manned sixth-generation fighter to a smarter, more cost-effective system of systems approach. Air Force Secretary Frank Kendall stressed the importance of this review, saying it will help decide if the Air Force should continue with a manned NGAD fighter or shift to a strategy using multiple connected platforms. The review will also study how unmanned systems, like collaborative combat aircraft, can work alongside or even take over some tasks of traditional fighter jets. This could lead to a bold new way of achieving air superiority, combining human pilots with advanced autonomous technology for a more flexible and efficient force. The B-21 Raider seems to be playing a key part in this review, as the Air Force considers giving the advanced stealth bomber a bigger role in shaping the future of air dominance. This isn't surprising, given the B-21 has already earned the title of the world's first sixth-generation aircraft, combining cutting-edge technology with unmatched stealth capabilities. As the Air Force explores its next steps, the B-21 may go beyond its traditional bombing missions, becoming a central player in a broader air dominance strategy. Its advanced systems and versatility make it a strong contender for tackling evolving threats in ways that go beyond the typical role of a bomber. This review could redefine the B-21's place in modern warfare, showing that its potential goes far beyond what was initially envisioned. The future of air power might rely heavily on this groundbreaking aircraft. Earlier this year, Air Force Secretary Frank Kendall called for a strategic pause to carefully evaluate the direction of the NGAD program. The pause reflects a growing realization that modern warfare is rapidly evolving, with autonomous systems like collaborative combat aircraft playing an increasingly important role. This shift has prompted the Air Force to revisit its original plans and reconsider whether a manned sixth-generation fighter is still the best solution for future air superiority. Rather than continuing forward without question, the review is taking a step back to the very beginning. It aims to re-examine the fundamental requirements for the next-generation aircraft, ensuring it aligns with the changing nature of threats and advances in technology. The Air Force is weighing whether a mix of manned and unmanned platforms could better meet operational needs while addressing cost and efficiency concerns. This reflective approach signals a willingness to adapt and innovate, embracing the possibilities offered by autonomous systems while carefully evaluating how a manned sixth-generation fighter fits into the broader picture. The results of this review could lead to a major shift in strategy, potentially redefining what air dominance looks like in the years ahead. Vice Chief of Staff James C. Slife explained that the Air Force is revisiting its approach to air superiority by reevaluating its fundamental goals. He suggested that the key question might not only be about building a sixth-generation manned fighter, but also about finding the best way to achieve air superiority in contested environments. These are related but distinct challenges, requiring a broader perspective. Initially, the focus was on developing a state-of-the-art fighter with unmatched capabilities. However, the emphasis is now shifting to a more integrated strategy. This new approach considers how systems like collaborative combat aircraft, advanced bombers such as the B-21, and a distributed network of platforms can work together. Unmanned systems might complement manned fighters, reducing dependence on costly, traditional, sixth-generation aircraft. A major factor influencing this shift is the rising cost of the NGAD program, with each aircraft estimated to cost hundreds of millions of dollars. Under Air Force Secretary Frank Kendall's leadership, the service is exploring ways to make the program leaner and more efficient. This includes spreading the NGAD's capabilities across multiple systems, which could help lower overall costs while maintaining effectiveness. Also, the Air Force appears to be moving away from focusing on a single, highly advanced fighter jet, and instead leaning toward a more flexible, network strategy. This would involve combining unmanned systems, bombers, and more cost-effective fighters into a coordinated system. Air Force Secretary Frank Kendall had already hinted that the program might shift significantly to reduce costs, aiming for a unit price lower than the F-35. Vice Chief of Staff James C. Slife supported this shift, suggesting that distributing capabilities across multiple platforms could redefine air superiority. Slife explained that advanced system integration now allows for a more disaggregated approach. For instance, instead of having all capabilities in one fighter, radar systems could be located separately from munitions, creating a broader and more adaptable network of assets. General David Albin also shared a conceptual idea called the light fighter, though it was later revealed to be an AI-generated concept used for a presentation. Albin emphasized the need to shift from the traditional built-to-last mindset of past decades to a built-to-adapt approach. He highlighted that many older aerospace systems were designed under the assumption they would remain relevant far into the future, a notion that might no longer hold true in today's rapidly evolving technological landscape. Focusing on the F-35, a formidable aircraft that has also been a source of much debate, its maker calls the F-35 a stealthy, fast, and the future of global air dominance, while a recent book titled The Trillion-Dollar Train Wreck, written by respected analyst Bill Sweetman, paints a very different picture. Both of these perspectives have some validity, but today most attention on the F-35 is focused on the issues plaguing the program. These challenges are largely tied to problems with the Technology Refresh 3 upgrade, which has led to a suspension of F-35 deliveries. Since July 2023, all aircraft coming off the production line, built to TR-3 standards, have been placed into storage while awaiting a solution to allow the new configuration to be certified. In testimony before the House Armed Services Tactical Air and Land Forces Subcommittee on April 16, Air Force Lieutenant Gen Mike Schmidt, the head of the F-35 Joint Program Office, admitted that he was getting tired of over-promising and under-delivering. He outlined ongoing issues with the Technology Refresh 3 upgrade, expressing frustration at being unable to provide a specific date for when the F-35 would be delivered as promised. Schmidt acknowledged the need to change the narrative around the program. This situation has sparked anger in Congress, with senior members of the House Armed Services Committee pushing for a reduction in F-35 procurement in FY25 to 58 aircraft, 10 fewer than the 68 requested by the Department of Defense, and 18 fewer than the 76 in the House's FY25 defense spending bill. They proposed using the excess funds, around $526 million, to support development, production, and testing aimed at fixing F-35 performance issues. Congressman Adam Smith of Washington the senior Democrat on the committee, and his colleague Donald Norcross of New Jersey, the senior Democrat on the Tactical Air and Land Forces panel, issued a statement saying, "At a projected total life cycle cost of over $2 trillion, the F-35 is the largest program in DoD history. Yet it frequently fails to meet its cost, schedule, and performance targets. This is unacceptable program execution, and Congress should not reward this behavior by buying additional aircraft above the president's budget request." Congressman Seth Moulton recently tried to amend the National Defense Authorization Act to allow the Secretary of Defense to open up the F-35 program to competition. This amendment would involve taking Lockheed Martin's intellectual property, enabling other companies to work on the F-35 software problems. The issues affecting the TR-3 upgrade are just the latest in a series of challenges for the F-35 program. As recently as 2019, there were still 13 critical deficiencies, including some classified as Category 1B problems, which had a critical impact on mission readiness, and others as Category 1A issues, which posed a risk to the operator's life. One particularly unusual problem was finding that prolonged supersonic flight could damage the F-35B and F-35C's structure and surface coatings. For the F-35C, there are restrictions on how fast it can fly. It's limited to Mach 1.3 in afterburner for no more than 50 cumulative seconds. The F-35B can only fly at Mach 1.2 or 18 cumulative seconds, or for 40 seconds at Mach 1.3. This likely prevents the F-35C from reaching the optimum Mach 1.44 speed required for beyond visual range weapon launches. Other issues include a technical problem with the cockpit pressure regulation system, causing severe sinus pain in pilots. There have been multiple issues with the F-35 helmet, with the latest problem being related to the night vision camera. This camera could display horizontal green lines, making it harder for pilots to land on ships when there was little ambient light. The TR-3 upgrade seemed like it should have been straightforward, as it was a relatively minor modification designed to prepare for the upcoming Block 4 suite of upgrades. TR-3 was meant to provide the additional computing power needed for new sensors and weapons, modernize the F-35 computational core with a new L3 Harris integrated core processor, add upgraded memory capacity, and feature a new panoramic cockpit display. TR-3 would also replace the underperforming Autonomic Logistics Information System with the new Operational Data Integrated Network System, which manages F-35 maintenance and spares. However, despite its modest scope, technical issues with TR-3 have caused the upgrade to fall 3 years behind schedule, resulting in a $330 million increase in the F-35 development costs, according to the U.S. Government Accountability Office. This reflects failures in Lockheed Martin's and the JPO's C2D2 methodology, as well as the technical complexity challenges associated with both hardware and software. C-2-D-2 was intended to deliver half-yearly software updates, each with 4 capability increments adding new features. However, this plan has not been followed. The June 2020 software build contained no fewer than 10 increments, with 4 specifically addressing software defects. Flight testing for TR-3 began on January 6, 2023, when Major Ryan Bolo Lurson of the 461st Flight Test Squadron conducted the first flight of an F-35 in the TR-3 configuration at Edwards Air Force Base in California. This flight test squadron, known as the Deadly Jesters, is the Department of Defense's lead unit for developmental flight tests on sensors, weapons, and software across all 3 F-35 variants. From August 2022, they received 6 brand new F-35As to test the Technical Refresh 3 and Block 4 configurations. These 6 aircraft were necessary to conduct the complex test missions, including using a 4-ship of instrumented test F-35s with TR-3 and another 4 TR-2 aircraft, to fully assess the warfighting systems and capabilities of the aircraft. Flight testing quickly revealed that there was a big difference between the software stability on the ground in Lockheed Martin's fully representative laboratory rigs and the stability of the same software when it was flown live on F-35 flight test aircraft. There's little confidence that a solution to this software stability problem will come quickly or easily. Deliveries planned for July 2023 were pushed back, with Lockheed Martin originally aiming for a new target of April to June 2024. This deadline was also missed. The first production F-35 in an early version of the Tech Refresh 3 configuration was flown during the week beginning November 13, 2023 at Fort Worth, but it couldn't be delivered after this initial vehicle system checkout flight, nor the series of acceptance flights that followed. A handful of other TR-3-enabled production F-35s have been flown, but most aircraft coming off the production line went straight into storage. The JPO said these initial production test flights would allow the final acceptance flight process to move more quickly once the software is finally approved for operational use. As recently as May 2024, the GAO reported that the software problems were still ongoing, with some test pilots having to reboot their radar and electronic warfare systems mid-flight to get them back online. Moving on, the rise of collaborative combat aircraft is changing the Air Force's vision for air dominance. As autonomous technology advances faster than expected, some experts now question whether a manned sixth-generation fighter is as critical as once thought. Instead, pairing CCAs with existing platforms like the F-35 and F-15EX offers a more affordable, flexible path to maintaining air superiority. This shift highlights the Air Force's move toward a system-of-systems strategy where manned and unmanned platforms work together. This approach not only reduces reliance on costly manned jets, but also allows for more adaptable and resilient operations. CCAs can take on various tasks, from surveillance to combat, acting as force multipliers while handling high-risk missions that would traditionally require human pilots. The Air Force is accelerating CCA development with plans to field over 150 units within 5 years. These unmanned aircraft are designed with modular systems and open architectures, making upgrades faster and maintenance simpler. This flexibility ensures the latest technologies can be integrated seamlessly, keeping the Air Force ahead in rapidly evolving battle scenarios. By combining cutting-edge autonomy with adaptability, CCAs are paving the way for a new era of air power. In early 2020, Anduril Industries and General Atomics reached a major milestone by securing contracts to design and test production-ready collaborative combat aircraft. These advanced drones are being developed to work alongside the future NGAD fighters, as well as current aircraft like the F-35. Their roles will include sharing sensor data, coordinating maneuvers, and even taking on combat tasks. The Air Force plans to deploy a diverse fleet of over 1,000 CCAs. These drones are being designed with modular systems, allowing them to carry different weapons and sensors while quickly adapting to various missions. A big breakthrough this year was the February 2024 maiden flight of the XQ-67A, a low-cost drone created by General Atomics under the Off-Board Sensing Station program. This drone, along with the earlier XQ-58A Valkyrie, highlights the common chassis concept. By using shared components for multiple drone models, the Air Force aims to streamline production and cut costs. This strategy allows for a scalable, budget-friendly solution to enhance combat capabilities without relying on expensive manned jets. It also aligns with the Air Force's push for distributed, resilient forces in a time of tightening budgets and evolving threats. The B-21 Raider is taking on an increasingly important role in shaping the Air Force's future. Initially designed as a long-range stealth bomber, the B-21 is now being considered for missions beyond its traditional purpose, including tasks typically reserved for fighter jets like air superiority. This potential shift highlights the Raider's versatility and its place in the evolving next-generation air dominance strategy. General David Alvin recently hinted at a broader role for the B-21, though he stopped short of confirming air dominance or air-to-air combat missions. However, this isn't the first time such possibilities have been discussed. Back in 2 Arvo, Major General Scott Pluce suggested that the B-21's stealth and advanced capabilities could allow it to take on air-to-air combat roles and contribute to air superiority in contested environments. He argued that thinking of it strictly as a bomber might limit its potential. Instead, the B-21 could become part of a larger family of systems, working with other platforms to ensure dominance in the skies. This expanded role could redefine the way the Air Force approaches 6th generation aircraft. By integrating the B-21 into missions traditionally handled by fighters, the Air Force is exploring how stealth, versatility, and advanced technology can combine to address modern threats. With its ability to defend itself and collaborate with other systems, The B-21 might represent a new kind of multi-role aircraft that adapts to the challenges of highly contested battlefields. The B-21's capability to operate in challenging environments and carry different types of payloads makes it a versatile choice. Since the bomber is already in production, expanding its role could offer a more immediate and cost-effective alternative to the NGAD fighter for certain missions. The deadliest war machine in American military history is back in action, and it's about to redefine global aerial combat. The thunderous F-15EX Eagle II emerges as a spine-chilling technological marvel that could instantly turn enemy skies into a nightmare battlefield, all the while remaining virtually invisible to adversarial radar systems, making rival nations tremble. Are you ready to witness the most advanced fighter jet ever constructed? Can you imagine the terrifying technology hidden inside this aerial monster? Join us as we discover how ready the new FX Eagle is for battle. In the high-stakes aerial arena of the Cold War, a single Soviet aircraft catalyzed one of the most pivotal technological advancements in military aviation history. On a scorching day in July of 1967, the Soviet Union unveiled the MiG-25 Foxbat at the Domodedovo Civil Airport, an event that profoundly alarmed United States military intelligence. This formidable display of aviation engineering marked a turning point, igniting a race to counter what was perceived as a significant threat to Western air superiority. The MiG-25 was anything but ordinary. Made mostly from stainless steel, it was a groundbreaking achievement in aerospace engineering. With its twin vertical stabilizers and engines that could exceed Mach 2, this interceptor showcased advanced technology that posed an immediate challenge to Western air dominance. Western military experts were shocked. The Foxbat's incredible speed and advanced radar exposed major weaknesses in American fighter jets. Although Soviet engineers capped the aircraft's speed at Mach 2.83 to avoid damaging its engines, its capabilities were groundbreaking. The United States Air Force saw an urgent need for a fighter that could match and completely surpass Soviet technology. Their last similar air superiority fighter, the F-86 Sabre from the late 1940s, was now outdated and no longer up to the task. The MiG-25 did more than highlight Soviet engineering skills. It sparked a wave of innovation in American military aviation. Its arrival forced the United States to rethink its approach to aerial combat, driving engineers to push the limits of fighter jet design. The Soviet Union, by pushing the United States to innovate, had unintentionally sped up the creation of its future competitor. The F-15 Eagle was more than just a response to the MiG-25. It became a landmark achievement in American aerospace engineering. When the Soviet MiG-25 Foxbat threatened American air superiority, the question arose: could the United States create a fighter that wouldn't just match it, but completely take control of the skies? The solution came from a combination of engineering breakthroughs, competition, and careful military planning. In December 1967, the United States Air Force launched a crucial program with one clear goal: to create a fighter jet that could revolutionize air combat and outperform all Soviet aircraft, present or future. This effort became a key turning point in the history of modern military aviation. By December 1968, contracts to design what would become the F-15 Eagle were awarded. This program stood out from typical military projects. The Air Force demanded quick results, cutting-edge innovation, and a bold new approach to fighter jet design. The competition was fierce, with several aerospace companies submitting innovative designs. Each proposal was carefully evaluated for its ability to excel in future air combat situations. General Dynamics and McDonnell Douglas were the first to enter this high-stakes race. The goal was clear: design an aircraft that could outmatch any current or future Soviet fighter. It wasn't just about building a plane, it was about ensuring national security in one of the most competitive fields possible. By December 1968, the design contracts for the F-15 Eagle were officially given out. The selection process was unusual. In December 1969, McDonnell Douglas was awarded the F-15 contract without a typical competitive fly-off, which surprised many military aviation experts. Critics worried that this method could result in higher costs and delays in the program. The Air Force had a clear plan: By speeding up the development process, they aimed to quickly produce and deploy the fighter. This risky decision turned out to be a success, and the F-15 Eagle became one of the most successful aircraft development programs in military history. The initial design goals were ambitious. The F-15 was meant to be a dedicated air superiority fighter, a role that hadn't been filled since the F-86 Sabre in the late 1940s. Engineers initially aimed for a top speed of Mach 3, but this was later adjusted to Mach 2.5 to help control production costs. Aerospace engineers faced many challenges behind the scenes. They had to design an airframe that could handle high speeds, carry heavy weaponry, and stay highly maneuverable. Every detail was carefully planned, from the wing design to the placement of the engine. The aircraft's engines were crucial to its performance. The F-15 was initially powered by Pratt & Whitney F-100 engines, each producing 25,000 pounds of thrust. This was groundbreaking at the time, giving the plane exceptional acceleration and climbing ability. Structural strength was a top priority. The design had to handle high G-forces, quick acceleration, and possible combat damage. To achieve this, aerospace engineers used advanced materials and computer modeling, techniques that were at the forefront of technology in the late 1960s and early 1970s. The first F-15 prototype flew in 1972, marking an important milestone in military aviation. By 1976, it was a key part of the United States military's fleet. The F-15 wasn't just a new fighter. It represented a clear display of technological superiority. What made the F-15 stand out was its overall design. Unlike earlier fighters that had to compromise between speed, maneuverability, and weapon capacity, the Eagle balanced all three. It could engage multiple targets at once, carry a lot of weapons, and outmaneuver most other planes of its time. The critics who predicted cost overruns and delays were proven wrong. The F-15 program became one of the most successful aircraft development projects in Air Force history. Its design would go on to shape the development of fighter aircraft for many years. The development of the F-15 happened alongside major technological advancements. In the early 1970s, there were rapid improvements in avionics, radar systems, and materials science. Each of these breakthroughs was incorporated into the F-15's design, making it a constantly evolving aircraft. The F-15's versatility was impressive. Originally built for air superiority, it was later adapted for various roles, including air-to-air combat and ground attack missions. This flexibility became a key feature of the F-15's legacy. By the late 1970s, the F-15 had become more than just a fighter jet. It stood as a symbol of American aerospace engineering, a technological achievement that would shape an era of military aviation. As the first F-15s were built and flown, few could have predicted how iconic this fighter would become. The skies now had a new predator, and it was called the Eagle. Would this groundbreaking fighter change aerial combat for good? The world would soon see. The F-15 Eagle became a remarkable fighter that would change the rules of air combat. Its performance was exceptional, creating a combat record that would go down in military aviation history. In air-to-air combat, the F-15 achieved an impressive record. Over 100 confirmed victories with no losses. This success turned the aircraft into a symbol of aerial dominance. Pilots called it the Air Superiority King, a title it would hold throughout its service. The F-15's ability to carry weapons was also impressive. It could carry up to 23,000 pounds of armaments and strike targets up to 100 miles away. Its advanced nose-mounted radar system allowed pilots to track and attack multiple enemy targets at once, giving American forces a major strategic advantage. Durability was another key feature of the F-15's design. With fewer than 2 aircraft lost for every 100,000 flight hours, the Eagle showed impressive resilience. This reliability allowed pilots to push the aircraft to its limits while keeping safety standards high. The F-15 stood out for its ability to perform multiple roles, making it a groundbreaking force in military aviation. Unlike other fighters of its time, which were often limited to specific tasks, the F-15 could easily carry out a wide range of operations. The F-15 was highly effective in air superiority missions, where it could intercept and neutralize enemy threats. It also performed well in precision ground strikes, electronic warfare, and reconnaissance. This versatility made it an essential asset for military planners, able to adapt to changing combat situations. The F-15 was equipped with advanced targeting systems that changed the way aerial combat was fought. Its radar and weapons worked together, allowing pilots to engage multiple targets from long distances with great accuracy. With its long-range missiles and advanced electronics, the F-15 could take out enemies before they even had a chance to detect the threat. This increased the success rate of missions and also intimidated enemy forces, who knew they were outmatched in both technology and strategy. By turning traditional close-range dogfights into precise, long-range engagements, the F-15 changed the way modern air battles were fought and set a new standard for air superiority. The F-15's success wasn't just due to its power. It was a combination of advanced engineering, smart design, and the latest technology. Each mission added to its reputation as more than just a plane. It became a crucial asset that could change the outcome in complex military situations. With its impressive combat performance, could the F-15 keep up with the fast-changing technology in modern warfare? As new weapons and radar technologies quickly changed military operations worldwide, the F-15 faced a crucial moment. Despite its impressive track record, the fighter was starting to show its age, and military planners saw the need for a major upgrade. The global political situation was shifting rapidly. New technologies from other countries were creating challenges that the original F-15 design couldn't easily overcome. Stealth features, advanced electronic systems, and new radar technology were making older aircraft more vulnerable. The United States Air Force was facing a tough challenge. The F-15, which had been a top performer in aerial combat for many years, was becoming outdated. New weapons and radar systems had advanced far beyond what the fighter was designed to handle, creating serious limitations in its operations. Production of the F-22 Raptor had stopped, and the F-15 fleet was quickly becoming outdated. The new F-35 Lightning II was facing delays, creating a gap in air superiority. Military planners needed a quick and practical solution to keep their technological edge. This situation wasn't just about staying ahead of potential threats. It was about making sure one of the most successful fighter jets in military history remained effective. The F-15 needed more than small updates. It needed a complete redesign of its capabilities. Military engineers and strategists started looking for ways to upgrade the F-15. They needed a solution that would bring new technology to the aircraft while keeping its key strengths. The goal was simple: turn the F-15 into a modern, high-performance combat system. The upgrade had to focus on several key areas: better electronic systems, stronger radar, more weapon options, and a longer service life. It wasn't just about keeping the F-15 performing well, it was about rethinking its future potential. The aging F-15 faced a tough challenge. But could a major upgrade bring this legendary fighter back for a new era of warfare? Boeing's F-15X Eagle II was a major breakthrough in fighter design. This twin-seat version wasn't just an upgrade, it redefined aerial combat capabilities and pushed the limits of what military engineers had previously believed possible. The most groundbreaking feature of the F-15X Eagle II was its advanced weapon system. Military strategists had always wanted a fighter that could engage multiple targets at once with high accuracy. The Eagle II made this possible, allowing it to launch up to 22 air-to-air missiles in a single mission. This turned the aircraft into a powerful mobile arsenal capable of neutralizing entire squadrons before they had a chance to react. The F-15X Eagle II also gained the ability to carry hypersonic weapons, adding a new level of strategic power. With the ability to carry weapons as long as 22 feet, the Eagle II could strike targets at incredibly long ranges and high speeds, something that would have seemed impossible just 10 years ago. This made the aircraft a formidable opponent, capable of hitting targets from far beyond the horizon with missiles that could outrun traditional defense systems. The Eagle II's electronic warfare system was a major advance in defensive technology, the BAE Eagle Passive Attack. Warning survivability system did more than just defend the aircraft. It could detect and track electronic threats, even neutralizing them before they became a real danger. This gave American pilots a significant edge in combat by improving their ability to respond to threats quickly and effectively. The Eagle II's engines, the twin General Electric F1 10G129, were a major performance improvement. Each engine could produce nearly 30,000 pounds of thrust, allowing the aircraft to reach speeds close to Mach 2.9. This made the Eagle II one of the fastest fighter jets in the world. The engine design combined incredible power with impressive fuel efficiency, a result of years of advanced engineering. Digital technology greatly improved how the Eagle II operated. The cockpit now featured touchscreen controls, making it much easier for pilots to manage complex missions. This reduced the workload for pilots and made missions more effective. The aircraft also had digital fly-by-wire controls, offering a level of precision and responsiveness that previous fighter jets couldn't match. The APG-82 Vi-1 radar system on the Eagle II was a major leap forward in target tracking. With greater range and accuracy, it could track and engage multiple targets at once with impressive precision. This wasn't just a small upgrade. It completely changed the way aerial combat would be fought. The F-15EX was designed with an open mission systems architecture, which allowed it to easily incorporate new technologies as they emerged. Unlike older fighters that were stuck with fixed configurations, the Eagle II could keep up with new threats and advancements, making it capable of staying relevant for decades. The F-15EX had impressive network capabilities. It could work on its own in remote areas or easily connect back to global systems. This flexibility allowed it to handle a wide range of missions, from detailed reconnaissance to large-scale aerial combat. The Advanced Suite 9.1 software, which was compatible with older F-15 models, made it easy to integrate the new system and reduce training needs for current pilots. This allowed pilots to quickly adapt to the new platform, keeping operational readiness high. With its remarkable features, could this new fighter change the future of air combat? The F-15X Eagle II wasn't just a simple upgrade. It was a powerful statement of American aerospace engineering, showcasing innovation and offering a preview of the future of military aviation. The Eagle II's advanced technology had changed air combat, but could this groundbreaking fighter attract the attention of military forces worldwide? The process of acquiring the F-15EX started in February 2019, marking an important moment in modern military aviation. The United States Air Force launched a plan to purchase at least 98 units, with the first 8 aircraft contracted in July 2020. Boeing's production plan was carefully planned. At first, the company produced 3 jets every 2 months, intending to increase this to 2 jets per month by 2025. This steady pace allowed them to maintain high quality and keep improving the technology. The acquisition process was carefully planned. The first 8 F-15EX aircraft were set aside for developmental and operational testing and were deployed to Eglin Air Force Base in Florida. At the same time, 2 F-15EXs were sent to the Oregon Air National Guard, starting their integration into active service. A key milestone was reached in March 2021 when the United States Air Force officially accepted the first Eagle II. The aircraft's initial operational capability was achieved a bit later than expected, with Air Combat Command Chief General Kenneth Wilsbach confirming its readiness in July of that year. The F-15EX quickly garnered global interest due to its advanced capabilities and technological edge. Countries recognized its potential to enhance their air defense and strengthen military readiness. As a result, nations such as Japan, Israel, South Korea, Saudi Arabia, Qatar, and Singapore acted swiftly, placing orders to integrate the F-15EX into their fleets. These countries valued its versatility, cutting-edge weapon systems, and ability to operate in complex combat situations, seeing it as a strategic asset for future defense needs. Each international order was more than just a military purchase. It was a sign of trust in the technology, a recognition of the F-15X's advanced capabilities, and an acknowledgement of its ability to change aerial warfare strategies. The fighter's versatility made it highly attractive to various military forces. It could carry a wide range of heavy weaponry, including air-to-air and air-to-ground missiles, making it adaptable to different combat scenarios. Its advanced electronic systems, including radar and electronic warfare capabilities, enhanced its ability to detect and engage threats in complex environments. Additionally, for the United States, the procurement strategy had several key goals. It helped address the aging F-15 fleet's shortcomings, provided a bridge between current fighters and future 6th-generation aircraft, and ensured continued American leadership in military aviation. The $1.2 billion contract with Boeing was more than just a financial deal. It was an investment in national security, a pledge to maintain air superiority and a sign of continued innovation in aerospace engineering. The second batch of jets is set to be delivered in late 2024, further advancing global air combat capabilities. Each aircraft reflects years of engineering, strategic planning, and technological innovation. Could the global deployment of the F-15EX mark the start of a new era of international military cooperation and technological progress? The Eagle had spread its wings, ready to soar into a new chapter of aerial dominance. The United States has just built a weapon that could change the future. With countries like China and Russia becoming even more technologically advanced, the U.S. is set to unveil a brand new $1 billion hypersonic laser that is super fast, very powerful, and super smart, making it the most advanced tool ever created for defense. What makes this laser so special? What are the advanced capabilities of this weapon that make other countries so nervous? Join us as we explore the amazing features of the United States deploying $1 billion hypersonic laser that is terrifying China and Russia. The hypersonic laser is a powerful system that has changed the way modern defense works. It is not like the ordinary weapons the world is familiar with. Instead of just firing bullets or missiles, it makes use of concentrated light to destroy its targets. And this makes it faster, more accurate, and very cheap to operate compared to other systems. The power of this laser comes from a special process known as spectral beam combining, and this technology can take many laser beams and combine them into a single but powerful beam. This combined beam can be focused with its extreme precision, making it a perfect weapon for hitting fast and moving targets like missiles and drones. Older weapons rely on ammunition, but this system is different as it uses energy, which makes it not only faster but also more efficient. One of the features that makes it special is this laser's immediate response, because it can be fired as soon as it identifies its target. This fast reaction is important when the United States is dealing with advanced threats like hypersonic missiles that can travel at speeds that are greater than 5 times the speed of sound. Old defense systems will struggle to intercept these missiles because they move too fast. But this hypersonic laser's speed and its accuracy provide a different solution. Another amazing part of the laser is its low cost per shot. Unlike other missiles that can cost millions of dollars each, but this laser costs only a few dollars. This makes it useful for long-term conflicts where expenses for older weapons cost a lot. As long as the hypersonic laser has access to any power source, it can fire as many times as possible without the need to reload or resupply. The weapon is very flexible as it can be used on different platforms like trucks, ships, and most importantly, an aircraft. This ability to move allows it to be deployed wherever it is needed the most. The U.S. Army is also testing lasers on vehicles in order to provide soldiers with a better way to defend the country against drones and missiles. The Navy is also providing ships with similar systems to protect their fleets from all kinds of threats, and this ensures that the laser can adapt to different combat situations. The hypersonic laser can fully focus on targets that are moving fast or trying to avoid being detected, and this high level of accuracy can reduce the risk of damage, which makes it a better choice for operations done in areas where the civilians are. Whether this weapon is taking down a smaller drone or a larger missile, it can be so accurate, ensuring that the target is completely destroyed. In order to keep the system of the weapon functioning effectively for a long time, the laser has an advanced cooling system, and this prevents the weapon from overheating, which is always a common standby, and this ensures that it can keep working without any interruptions. Hypersonic missiles are very fast and can easily change direction in order to avoid being intercepted, and this makes it almost impossible to counter them with older systems. Dealing with this type of missile has been one of the biggest challenges in modern defense, but this advanced laser weapon has an advantage over other weapons with its speed and precision, providing a way to destroy these advanced threats before they can cause any damage. The easy use of the weapon makes it suitable for a wide range of missions, as it can defend a military base, protect a naval fleet, or even support troops on the ground, and the system can adapt to different needs. The use of the laser weapon has gone beyond what an old defense system can do, as this weapon can be used in space to protect satellites from attacks and particles in space that might cause damage. Let us take a look at the most powerful hypersonic weapon built by the Chinese and Russians, which are being terrified by the United States hypersonic laser weapon. The DF-ZF is one of the best hypersonic weapons made by China. It is a hypersonic glide vehicle that has people talking about it because it is very special and powerful for its advanced abilities. When most fast weapons are launched, they follow just a single direction, but this weapon is different. It can turn and change direction while flying, and this makes it hard to guess where it is going and hard to stop. Being able to turn and also super fast makes it a big achievement and a strong weapon. This great weapon was on top of a big rocket known as the DF-17 missile, and this rocket helped it go up very high into the sky. Once it is high enough, the DF-ZF separates from it and flies on its own towards its target. Regular rockets follow a simple and easy path, but this weapon is different as it can turn and go up and down as it flies, making it hard for radars and defense systems to either see it or stop it. Its path keeps changing always, and this makes it difficult for the enemies to detect its direction, making it hard to destroy. One amazing thing about this hypersonic weapon is how fast it can go. It can fly at speeds 10 times faster than the speed of sound, and even quicker, and at this speed it can travel thousands of miles in a few minutes. It moves so fast that other defense systems do not have enough time and weapons to stop it. This is unique because it is faster than most military systems, and this makes it useful for destroying important targets quickly. It is also flexible in the sense that it can carry different kinds of weapons, and it can carry more like regular explosives, which are used to hit targets, or it can be used to carry nuclear weapons for very big damage. This makes it useful for many jobs, like breaking into the enemy's defenses or trying to deliver a very strong attack. This feature has made it an important part of Qin's plan to scare their enemies and keep them from attacking. The process of building the DF-ZF was very complex, and flying it created a lot of problems, like extreme heat. Whenever it moves, the air rubbing against it makes the surface heat up to thousands of degrees, and the engineers had to make use of special materials and designs to keep it from breaking and melting. Making its guidance systems work perfectly at such high speeds was another challenge, because if the system makes a tiny mistake, the weapon will miss its target by a long distance. It has always been a part of the new race between big countries like the United States and Russia to make faster weapons. But this weapon is special because it can avoid defense systems and hit its targets quickly. For China, it is a big step forward in making its military stronger and trying to stay ahead of other countries. But the DF-ZF is not perfect because building it and testing cost a lot of money, and each test needs special places and careful planning, which always take time and money. Also, running this weapon needs engineers who are experts and a lot of resources, which makes it hard for the military to manage. Even with these challenges, the DF-ZF is mostly used, becoming very important to China's defense plans. By showing off this weapon, the country wants to prove that it can handle threats and protect itself in a world full of unknown wars. This weapon also shows other countries that China is a leader in making advanced military technology. It has made people around the world talk about more hypersonic weapons, like the Avangard built by the Russians. Even though this weapon is very powerful, it has brought more worries as it requires less time to think during a fight, which could lead to mistakes due to its ability to destroy targets very quickly. Some engineers are also afraid that weapons like the DF-ZF could make other countries rush to build their own, causing more competition and tension. This weapon shows how quickly military technology is improving with the way it is fast, can easily turn, and also does many things, giving a sign of how war might change. Old weapons are still useful, but the DF-ZF shows that weapons that are fast and hard to predict are as important as weapons that are slow but strong. It also shows that future battles might not be about who has most soldiers, but about who has the best and most advanced technology. The Avangard is a hypersonic weapon developed by the Russians, and it is one of the fastest and most powerful weapons in the world. With its incredible speed, it can reach its target within a minute, making it almost impossible for enemies to stop it. And this weapon is designed to outsmart other dense systems, giving it an advantage and showing the impact and a big change in how wars might be fought in the future. The way this weapon works is what makes it special because it does not follow the same path as the regular missiles. The Avangard is different from other advanced weapons It is carried into the atmosphere by a powerful rocket called an intercontinental ballistic missile, and once it reaches a very high altitude, it separates from the rocket and begins to fly through the air. Just like the DF-ZF, it does not just fly in a straight line, but instead it can twist, turn, and even change direction as it flies, making it very hard to track. What makes this weapon incredible is the speed, because it can travel at Mach 20, which is 20 times the speed of sound, and with this speed, most defense systems cannot keep up with it. Also, it is very dangerous because it gets really close to its target, but the enemy's radar can detect it, making it hard to avoid. It does not rely on speed only, but it is very smart as it glides towards its targets. It goes in a zigzag way, changing directions. This movement that cannot be easily predicted makes it hard to guess, and even the most advanced tracking systems struggle to follow its movements due to this ability. It is also powerful in terms of damages it can cause. It can carry either an explosive or bigger weapons that can destroy large buildings, and some can cause massive destruction over a wide area. This allows the avant-garde for different types of missions, as it can be used to target the military bases of the opponents in order to deliver a powerful blow. The ability to carry a nuclear weapon also makes it difficult for other countries to attack. Building this weapon was very hard because one of the problems the engineers faced was heat. When it flies at such high speed, it gets hot easily, making the materials used to melt. These engineers decided to use a special material that cannot melt and is strong and not too heavy. Another problem was to make sure it could hit its target at high speeds, because any mistake in the guidance system will not make it accurate and precise. Russia built the avant-garde in order to stay ahead of other countries in the military world. But the United States has been working on advanced defense systems like the $1 billion hypersonic laser that can shoot down any old or advanced missiles. The speed, agility, and ability to carry powerful weapons make this powerful missile hard to stop. This type of hypersonic weapon is so powerful, but still makes the Russians worried because of its speed and ability to change direction. Russia might not have enough time to make careful decisions in times of crisis, as a quick response might be necessary at the moment, leading to mistakes or big problems sometimes. A long time ago, having lots of armor tanks and planes made a country look stronger than others. But now that is not that, as these advanced weapons show how fast war technology is changing from quantity to quality of weapons. It is all about having the smartest and most advanced tools, and the avant-garde is a perfect example of this. It is super fast, accurate, and hard to build, making it a special weapon in modern battles. Just like other weapons, this weapon will be an example of both the problems and possibilities of what new technology will bring. One of the latest laser weapons that is built by the United States is known as the Athena system, and this stands for Advanced Test High Energy Asset. It is sleek, portable, and can fit into any military vehicle, and this makes it easy to move and use it in any different part of the country whenever it is needed. This creates a huge advantage where threats can come from different parts of the world, making it a powerful tool that can be used defensively. Athena works by firing a beam of light at its target, and this beam is so strong that it can heat up and destroy the surface of the target in seconds. Imagine focusing the sunlight on burning a piece of paper. That is how simple this laser can destroy any object. The laser beam is very accurate, and no matter how the target moves, it continues to follow the target until it makes a hit. This accuracy has reduced the risk of missing the target or damaging any nearby object because it is smart enough to only shine to the direction it is needed to. The design has special sensors that can help it detect and track threats, and these sensors all work together with the laser in order to ensure that the system can respond very fast. This means that when a drone or missile has been located, this laser will take it down before it gets close. Another feature is that it does not need bullets because it runs only on electricity, and this makes it so cheap to use than other normal weapons that require expensive bullets and weapons. Because of the use of a power supply, it can fire as many times as possible without running out of ammo. As long as it is connected to a power source, it will keep working, and this makes it reliable to defend multiple threats coming at once. Another good thing about this weapon is that it does not make any loud noise or leave any particles behind, and this makes it a cleaner and quieter option for defense. It is powered by what is called a solid-state fiber laser, which means it uses tiny fibers to create a very strong and focused beam of light. It can deliver up to 60 kilowatts of energy, and that is enough to take down drones, vehicles, and other threats. When it was tested, it destroyed multiple targets successfully, including moving trucks, by burning the truck through its engine from a long distance, and this shows how effective the system is against real targets. It can also be used in different places, like military bases, ships, or vehicles traveling through a dangerous area, and it can be placed on a truck to defend against different attacks. It can act as a shield that takes down incoming missiles before they reach important buildings like the White House, serving as an invisible wall of protection that works instantly. Aside from vehicles, it can also be used on ships to protect the Navy from attacks like unknown small boats that try to get too close will be destroyed if they pose to be a danger to the ship. The ability to operate in different environments is what makes it a valuable tool. Athena is improving daily in order to make it more powerful and effective, and it is planned to be taken to higher levels so it can be used to target larger and faster threats. It is planned to be combined with radars and advanced sensors so it can create a complete security network. But all these laser weapons cannot be compared to the latest hypersonic weapon developed by the United States, as it can deliver over 300 kilowatts of energy and it can counter other powerful laser systems. This system can perform in difficult conditions, such as bad weather or complex environments, and it can still hit its targets hidden inside the clouds. The development of this laser has completely changed the way military forces build their weapons by focusing more on speed and accuracy. The ability to destroy any hypersonic missiles and other advanced weapons shows how important it is to maintain military security. Engineers are checking for more ways to make the laser system even more powerful and efficient by increasing its energy output and improving its cooling systems in order to improve its performance. There is also a possibility of making laser systems on smaller weapons like drones, allowing the system to operate in dangerous areas without putting human lives at risk. And this can expand the capability of the laser and even open up new possibilities of its use in both military and civilian operations. The sea is home to some silent predators capable of leveling not just cities, but even countries in a matter of minutes. These nuclear submarines remain terrifying both in times of war and in times of peace, and the race for improving these deadly weapons for domination is a tight one. The United States has pulled ahead of the curve with its new submarine, as it tries to continue to protect its interests. What is the submarine capable of, and how would it help defend the United States against threats? Join us as we explore how the United States tests secret submarines to counter global threats. In March 2016, the United States Navy chose General Dynamics Electric Boat as the prime contractor to help build a nuclear submarine unlike anything ever witnessed, the Columbia-class submarines. This is not the first time the United States Navy would be partnering with Electric Boat, as Electric Boat helped build all 18 Ohio-class submarines, which are about to be replaced by the Columbia-class submarines. The Columbia-class program has only one goal: to design and build a class of 12 new ballistic missile submarines to replace the Navy's current force of 14 aging Ohio-class submarines. The United States Navy has placed the Columbia-class program as its top priority program and procured the first Columbia-class boat in 2021. As the Navy's top priority, the Columbia-class program will remain funded, and this might even come at the expense of funding other Navy programs. The Columbia-class submarine will be larger than the Ohio-class design in terms of submerged displacement, and therefore will be the largest submarine ever built by the United States. The Navy has also planned the Columbia-class to be fitted with the most up-to-date capabilities and stealth to ensure they are survivable throughout their full 40-year lifespan. The design and technology development of the Columbia-class was estimated to cost $4.2 billion. With technology and components from the Ohio and Virginia classes included where possible to save money. Building such a super submarine is bound to cost a lot of money. The cost to build the District of Columbia, the lead boat of the class, will be an estimated $6.2 billion. However, the Navy will try to cut costs where it can, as it has a goal of reducing the average cost of the remaining 11 planned hulls in the class to $4.9 billion each. The total life cycle cost of the entire class is estimated at $347 billion. The high cost of the submarines is expected to cut deeply into Navy shipbuilding. In April 2014, the Navy completed a 300-page specification report for the Ohio Replacement Program submarines. The Columbia-class program was known as the Ohio Replacement Program, ORP, or SSBN program, until 2016. Boats in the class were referred to as Ohio Replacement Boats, or SSBNs. Till now, some budget documents continue to use these terms. In a bid to reduce life cycle cost and acoustic signature, the Navy is set to make Columbia run on electric drive. That is, it will make use of an electric motor to turn its propellers instead of using the reduction gearing and mechanical drive systems used on earlier nuclear-powered submarines. The Columbia submarine will also retain the nuclear reactor and steam turbines typical of United States Navy submarines. In such systems, the nuclear reactor in the submarine heats water to steam, the turbines convert the heat and the steam into mechanical energy, and the generators convert that mechanical energy into electrical energy for use by the propulsion motors and other onboard systems. House of Representatives member Eleanor Holmes Norton declared the keel laid for the future USS District of Columbia. The ceremony marked the ceremonial construction start of the Columbia class that's expected to be commissioned in 2027. On October 28, 2020, it was announced by the Secretary of the Navy that the second Columbia-class submarine will be named the USS Wisconsin. The Ohio-class submarine ruled the seas and still does, at least until the Columbia-class submarine is launched. Thus, it was no surprise when the nuclear-powered submarine, which is equipped for precision missile strikes over considerable distances, joined a fleet of Navy ships in the waters of the Middle East to monitor and discourage the involvement of other nations in the conflict between Israel and Hamas. The colossal naval vessel provided the Navy not only with unprecedented strike and special operation mission capabilities from a stealthy, clandestine platform, but the role that they play in the nation's defenses cannot be understated. The submarine currently stands as a pinnacle of naval engineering, and it serves as a silent defender, swimming beneath the ocean's surface. Commissioned by the United States Navy, these formidable vessels are an important part of the nation's strategic defense. The silent sea predators were first developed during the Cold War as a response to the evolving challenges of the political world. The first-of-class USS Ohio set sail in 1981, and it marked the beginning of a new era in submarine technology. Originally designed as ballistic missile submarines, SSBNs, armed with Trident missiles, some of these submarines were later converted into guided missile submarines, showcasing their ability to adapt to the needs of the situation. One of the remarkable features of the Ohio-class submarine is its ability to operate stealthily. With its advanced sonar baffles, quiet propulsion systems, and a streamlined hull, it all contributes to its effectiveness in remaining undetected beneath the waves. This stealth is essential for both strategic deterrence and covert operations. The naval vessel submarines boast impressive dimensions, with a length exceeding 560 feet and a submerged displacement of around 18,750 tons. These submarines are the largest submarines ever built for the United States Navy, making them the world's third largest submarines. They are also powered by a nuclear reactor. These submarines can operate submerged underwater for extended periods, offering unparalleled endurance and range. In their SSBN configuration, Ohio-class submarines carry Trident ballistic missiles, a crucial component of the United States nuclear triad. They can deploy a diverse array of guided missiles and special operations forces. They are also designed for extended strategic deterrent patrols and are equipped with two complete crews, the Blue Crew and the Gold Crew, each typically serving 70 to 90-day deterrent patrols. The submarines also have 3 large logistics hatches that help to facilitate fast resupply and repair access, reducing the time required for replenishment and maintenance. These colossal submarines can carry up to 24 submarine-launched ballistic missiles with multiple independently targeted warheads, and their strategic weapon is the Trident 2D5 missile. Their powerful arsenal means that these submarines remain a testament to the United States' commitment to maintaining a robust, strong, and flexible naval presence. Their ability to navigate the world's oceans covertly allows them to contribute to global stability and respond rapidly to emerging threats. Despite the efficiency of the powerful Ohio-class submarines, the United States cannot wait to officially start using the Columbia-class submarines. But they have hit quite the snag in the launching of the submarine. Whilst the anticipation builds for a new age of nuclear-powered sea monsters, the United States Navy have suffered a huge blow, as there have been delays in the release of this new naval vessel. These delays are a result of contractor setbacks, including late delivery of the boast section by Huntington Ingalls Industries, HII, and turbine generators from Northrop Grumman. These delays may force the Navy to extend the service life of 5 Ohio-class submarines to maintain nuclear deterrence. With a life cycle cost of $358 billion, the Columbia-class program finds itself under intense scrutiny by lawmakers, as timely delivery and operational success are critical. The United States Navy's future Columbia-class nuclear-powered ballistic missile submarines, which are set to replace the aging Ohio-class boats, will eventually become a major component of the nation's nuclear triad. Each of the planned dozen boats will be equipped with 16 submarine-launched ballistic missile tubes, as opposed to 24 submarine-launched ballistic missile tubes on the Ohio-class SSBNs. That was meant to reduce construction, operations, and maintenance costs. In addition, the new ballistic missile submarines will utilize the Joint American-British Developed Common Missile Compartment, CMC, which will also be installed on the Royal Navy's new Dreadnought-class submarines. It was designed to launch the Trident 2D5 Intercontinental Ballistic Missile, ICBM. The joint effort has been reported to save each nation hundreds of millions of dollars. On paper, the Columbia class is just what the United States Navy needs to accomplish its nuclear deterrence mission. Back in reality, the situation is quite dire. At issue is the fact that there is now a delay of as much as 16 months in delivering the lead boat, the future USS District of Columbia. It was previously reported that the submarine could be delivered in fiscal year 2028, instead of the previously planned delivery. According to Bloomberg a few months ago, the future SSBN 826 delay could be as much as 16 months, and it stems from contractor delays in delivering the vessel's bow section and power generators, according to an internal assessment by the service. These delays have finally reached the ears of lawmakers. The delays impacting the Columbia class have been seen as very serious, as it could force the United States Navy to keep the Ohio class in service longer than expected. The original plan called for the first of the SSBNs to be retired beginning in 2027, with an additional boat leaving the service every year until 2040. Navy officials have said it could be possible to extend the service life of at least 5 of its Ohio-class subs by 2 to 3 years each, so that the force would remain at 12 vessels or more for all but 3 years between 2024 and 2053. General Dynamics Corporations and Huntington Ingalls Industries, HII, were charged with designing and constructing the 12-boat class, a roughly $130 billion program, with each sub assembled from 6 large hull segments. During construction, the super modules are each outfitted with systems and connections before final assembly by General Dynamics. Ideally, this was meant to speed the production. However, Huntington Ingalls Industries, HII, was to ship the bow in May 2025 from its Newport News, Virginia yard to the General Dynamics facility in Groton, Connecticut. It is now estimated for June 2026, 13 months late, according to internal service figures. The reason for the delays hasn't been made public. They revealed in a release statement that it experienced first-in-class challenges on a complex welding sequence, which required revising the plan for the largest submarines ever built in the United States. Huntington Ingalls Industries, HII, further stated that the revised plan was successfully executed and is now incorporated on follow-on ships. Whilst the United States boasts one of the strongest, if not the strongest, Navy, it is not the only country with a strong Navy. The United Kingdom also boasts a large and strong Navy, one of the strongest navies in the world, with their submarine, the Vanguard. The Vanguard was designed and introduced in the early 1980s by the Ministry of Defense, acting in one of its last Royal Navy Warship Design Authority roles. They were designed from the outset as nuclear-powered ballistic missile submarines, able to accommodate the UGM-133 Trident II missiles. As such, the missile compartment is based on the same system used on the American Ohio class, which is also equipped with the UGM-133 Trident II. This requirement led to the Vanguard class design being significantly larger than the previous Polaris-equipped Resolution class. And at nearly 16,000 tons, they are the largest submarines ever built for the Royal Navy. Due to the large size of the Vanguard class, the Devonshire Dock Hall in Barrow-in-Furness was built between 1982 and 1986 specifically for the construction of the boats. In 1985, both HMNB Clyde and the Royal Naval Armaments Depot Coalport at Fastlane underwent extensive redevelopment in preparation for the Vanguard-class submarines and Trident II missiles. Rosyth Dockyard was not left behind, as it also underwent significant redevelopment. The work included enhanced handling, storage, armament processing, berthing, docking, engineering, training, and refitting facilities at an estimated cost of $550 million. Prime Minister Thatcher laid the keel of the first boat, HMS Vanguard, on the 3rd of September 1986 at the Devonshire Dock Hall. Vanguard was launched in 1992 and commissioned in 1993. The year 1992 saw a fierce debate arise over whether the fourth vessel, Vengeance, should be cancelled. However, the Ministry of Defense ultimately ordered it in July 1992, and it was commissioned in 1999. And now the UK aims to upgrade their nuclear submarine system. As UK Defence Prime Babcock announces a contract for a deep maintenance and life extension, LifeX process for the nuclear-powered ballistic missile submarine SSBN, HMS Victorious, parallel programs are also running that will introduce an entirely new nuclear weapons capability to the Royal Navy. Revealing the estimated £560 million, the LifeX program with the UK Submarine Delivery Agency, SDA, on the 1st of March, the upgrade to HMS Victorious, one of 4 Vanguard-class SSBNs in service with the Royal Navy, will see the vessel continue well into the 2030s. The cost of HMS Victorious's maintenance is significantly more than the work carried out on HMS Vengeance, which underwent a refit from March 2012 to February 2016 at a cost of £322 and included a refuel of the boat's reactor and an update to its electronics and machinery. HMS Victorious is the second Vanguard-class submarine to undergo a LifeX package at Babcock's Devonport facility, which itself is undergoing an extensive modernization program that includes improvements to submarine sustainment facilities, including the ability to defuel decommissioned nuclear-powered submarines. Likely home for at least the next 4 years, 5 Basin at Babcock's Devonport Royal Dockyard houses HMS Victorious, which will require 7.2 million personnel hours of work to be carried out in order to provide a third and final commission for the vessel before it leaves service. HMS Victorious will see upgrades to 90% of its systems, including the combat management system, as part of its complex LifeX program. Once the LifeX of HMS Victorious is completed, Boat 3, HMS Vigilant, will take its place for its own refit. Meanwhile, in October 2023, the UK Royal Navy announced that construction of the largest segment of the future HMS Dreadnought, the lead boat of a new class of ballistic missile submarines, had been completed at the BAE Systems Submarine Yard in Barrow-in-Furness, Cumbria. The new class will replace the current Vanguard SSBNs in Royal Navy service. BAE Systems was originally contracted in 2012 to begin its initial design of the 4 future SSBNs, Dreadnought, Warspite, Valiant, and King George VI, and another detailed design task in 2015. Upon completion, the Dreadnought class will become the Royal Navy's largest submarine, with a length of 153.6 meters and a displacement of 17,200 tons. To date, 4 successors will be built, of which Dreadnought leads the way, ahead of HMS Warspite and Valiant, also under construction, with work yet to start on boat number 4, HMS King George VI. The 4 boats will replace the incumbent Vanguard class and are thought to feature new technologies derived from the new Astute-class nuclear-powered attack submarines, including a new pressurized water reactor design. Speaking in January 2024, UK Defence Procurement Minister James Cartledge stated that the Dreadnought program remained on track to replace the Vanguard class, at a cost within the original £31 billion, plus a £10 billion contingency budget made in the Strategic Defence and Security Review 2015. While the LifeX processes of the Vanguard class and the ongoing build of the new Dreadnought boats are well understood, the UK government has been engaged in secretive work to develop a new type of nuclear warhead that will form the centerpiece of the country's nuclear deterrent. Each of the Vanguard-class SSBNs can each carry up to 16 Trident 2D5 ballistic missiles, which contain up to 8 multiple independent targetable re-entry vehicles, or MIRVs, housing MQ-4A Holbrook nuclear warheads, with a yield of up to 100 kilotons. The new Dreadnought class will be able to accommodate 12 Trident 2D5 missiles. The nuclear weapon dropped on Nagasaki, Japan, during World War II had a reported yield of 25 kilotons. The UK maintains its nuclear warheads at the Atomic Weapons Establishment, AWE, Aldermaston in Burghfield in Berkshire, west of London, with the sites in 2020 announcing that they would be brought back into UK government control from a consortium led by US defense prime Lockheed Martin. In 2021, the UK announced that it would increase the number of nuclear warheads in stock from around 225 currently to about 260. The UK's current warheads are claimed to be of a UK design, but thought to be derived from the US origin W-76 weapon. The new UK warhead will be designed, developed, and manufactured in the UK and housed in the US MiG-7 aeroshell, which will house the planned W-93 warhead. The Mk-7 aeroshell will be procured from the US along with some other non-nuclear components under existing nuclear treaty arrangements, stated a 2023 UK parliamentary report. Although relatively little is known about the potential costs of creating a new nuclear warhead, it is thought that the UK could spend up to £4 billion on the program. In February 2024, it was revealed that the UK tests of the Trident 2D5 ballistic missile weapon system off the US East Coast had suffered a second successive failure, raising questions about the viability of the UK's nuclear deterrent.
Foreign fighter jets have taken to the skies, and the race for sixth-generation dominance has commenced. The United States, China, and Russia vie for supremacy in this era of modern military power. As the world watches, it becomes evident that the US is not alone in the arena. China is quickly ascending the ranks, forging ahead in the development of advanced weaponry. As rumors spread and leaked images surface, anticipation reaches a fever pitch. Will China's top-secret hypersonic aircraft with the capability to reach Mach 10 change the game of modern warfare forever? What cutting-edge technology lies behind its stealth and agility? Can it outmatch the United States' own sixth-generation fighter? In this video, we will explore China's quest to create the ultimate fighter, a top-secret hypersonic aircraft capable of reaching Mach 10. Fighter jets, the kings of the skies, have a storied history dating back to the early 20th century. During World War II, when countries tried to get the upper hand in the air over their enemies, they were made for the first time. Fighter jets have come a long way since those early days. In terms of technology and power, they have reached unimaginable heights. World War II was a pivotal time for fighter aircraft, as it witnessed legendary dogfights that left their mark on history. The legendary P-51 Mustang, renowned for its long-range escorting missions, engaged in a furious dogfight with the formidable German Messerschmitt Bf-109. These aerial battles demonstrated the significance of air superiority and established the foundation for future fighter aircraft. After World War II, aviation technology made great strides, ultimately leading to the development of supersonic planes. The F-100 Super Sabre was the first fighter to accomplish continuous supersonic flight in level flight. The Soviet MiG-21 was one of the most widely produced supersonic fighters in history due to its versatility and agility. The Cold War intensified the arms race between the United States and the Soviet Union, spurring the development of increasingly sophisticated fighter jets. As the 20th century ended, the fourth generation of weapons came into use. The F-15 Eagle, known for being the best at dogfighting, and its counterpart, the F-16 Fighting Falcon, which was great at aerial combat and ground attack tasks, showed how far technology had come in this generation. Fly-by-wire technology, which replaced traditional manual controls with electronic systems to improve maneuverability and precision, was one of the most important innovations in these planes. Stealth capabilities and integrated avionics were other defining features of fourth-generation fighters. The F/A-18 Hornet, capable of operating from aircraft carriers, showcased the importance of versatility in modern air warfare. These advancements set the stage for a new era of aerial combat. With the turn of the millennium, fifth-generation fighters stormed onto the scene, pushing the boundaries of what was thought possible. Redefining modern air warfare were the F-22 Raptor and the F-35 Lightning II. The F-22 Raptor was unparalleled in its stealth and air dominance capabilities, while the F-35 Lightning II boasted innovative sensor fusion and network-centric combat capabilities. These aircraft demonstrated the importance of information superiority and data sharing on the battlefield. On the other hand, the competition for air superiority never stops. As we move farther into the future, the creation of fighters of the sixth generation will assume a more prominent role. The United States of America has a highly secretive program called Next Generation Air Dominance, NGAD, that it uses to maintain its superiority in aerial combat. But, as the world looks on, China has emerged as a serious contender in this pursuit. Recent leaks suggest that China is working on its own sixth-generation fighter program, shrouded in secrecy and speculation. China's ambitions to dominate the skies have taken a significant leap forward with the unveiling of its highly anticipated sixth-generation stealth fighter. Locked in fierce competition with other global powers, the Chinese Aviation Industry Corporation has meticulously crafted a marvel of engineering and innovation. On January 31, 2023, the Aviation Industry Corporation of China, AVIC, boldly displayed the future of Chinese military aviation, making headlines around the globe. They lifted the veil of secrecy by unveiling detailed CGI concept art, giving the world a glimpse of the formidable capabilities of their hypothetical sixth-generation fighter. The aircraft's design is nothing short of revolutionary. Its twin engines give it unbeatable power, letting it turn quickly and go at very high speeds. Its diamond-shaped wings that don't reflect light and a blended body make it a cutting-edge opponent on the world stage. These improvements make the Chinese fighter more stealthy and improve its aerodynamics, giving it a clear advantage in any possible dogfights. As the virtual curtains were drawn, the public couldn't help but marvel at the sleek and imposing presence of the Chinese sixth-generation fighter. The excitement was palpable as aviation enthusiasts and military experts alike speculated on the aircraft's classified specifications. How does it achieve its remarkable stealth capabilities, and what state-of-the-art materials are used in its construction? To achieve air superiority in the sixth-generation fighter race, China is leaving no stone unturned in advancing cutting-edge technologies. At the heart of their efforts is a desire to improve the aircraft's stealth characteristics, rendering it almost invisible to hostile radar systems. The Chinese fighter, like its American and European counterparts, is intended to include an advanced sensor suite capable of not only detecting threats from afar, but also providing real-time data for educated decision-making during intensive aerial combat. But stealth is only half the equation. Maneuverability is equally crucial. To outmaneuver adversaries in dogfights and combat scenarios, China plans to employ state-of-the-art computer-assisted fly-by-wire systems. These systems enable unprecedented control over the aircraft, offering the pilot enhanced precision and agility in executing complex aerial maneuvers. By integrating these technologies seamlessly, China aims to match or even surpass the maneuverability of its competitors, solidifying its position at the forefront of the sixth-generation fighter development. China has invested heavily in hypersonic wind tunnel technology, which has been important to the country's progress in the field of hypersonic flight research. In order to simulate the extreme circumstances encountered during hypersonic flight, where velocities can approach incredible Mach numbers, these wind tunnels are built. China gains a significant advantage thanks to their technological prowess, which enables them to simulate and test their aircraft's performance at hypersonic speeds. With such a substantial investment in hypersonic research, China has propelled itself into a highly competitive position in the race for hypersonic-capable sixth-generation fighters. Hypersonic flying is a breakthrough technology that promises to rewrite the rules of engagement in the ever-changing world of air combat. Hypersonic aircraft, with speeds exceeding Mach 5, can cover large distances in a fraction of the time it takes ordinary planes. This disruptive potential has piqued the interest of military strategists around the world, as it provides a decisive advantage in both offensive and defensive operations. Imagine a fighter jet streaking across the horizon at Mach 10, a speed so blindingly fast that it shrinks reaction times to mere seconds. This speed gives pilots tactical benefits that have never been seen before, making it easy for them to beat their opponents. A hypersonic fighter can close the gap between targets in the blink of an eye, attack without being seen, and disappear over the horizon before an opponent can even respond. The holy goal of the modern air war is being able to strike with unmatched speed and reach faraway targets in the blink of an eye. But what lies at the core of China's hyperspeed prowess? At the forefront of the race for the next-generation fighter, China has harnessed cutting-edge technologies to develop a formidable aerial platform. By seamlessly integrating advanced radio-electronic equipment, state-of-the-art computer systems, and artificial intelligence, China's sixth-generation fighter promises an unparalleled blend of speed, maneuverability, and combat prowess. The design philosophy of the fighter is centered on enhancing aerodynamic efficiency, lowering drag, and optimizing lift to operate at hypersonic speeds efficiently. The tremendous thermal and structural strains of continuous hypersonic flight are tolerated by advanced materials such as lightweight composites and heat-resistant metals. But that's not all. The fighter's propulsion system is an engineering marvel, creating enormous thrust to push it through the rare air at astounding speeds. But what will this mean for the balance of power in the skies? As China surges ahead in developing hypersonic capabilities, it presents a formidable challenge to the long-standing dominance of the United States in aerial warfare. For decades, the U.S. has held a technological edge with its stealth capabilities and advanced fighter jets. Now, with China's rapid progress in hypersonic technology, the balance of power could shift dramatically. The competition intensifies as the United States, China, and Russia vie relentlessly for supremacy in the high-stakes sixth-generation fighter program. As we delve deeper into this battle of aviation giants, a compelling and revealing comparison emerges between the Chinese and American sixth-gen fighters. At the heart of this competition is not only the race to produce the most advanced aircraft, but also a strategic approach to design and technology. Both China and the U.S. know how important stealth, agility, and high-tech avionics are, but they do things in very different ways. The F-45 Spectre II represents a combination of principles learned from its predecessors, including the F-35 Lightning II and the F-22 Raptor. It has a modular design and uses artificial intelligence to seamlessly adapt to different mission requirements. The United States has always placed a premium on technological superiority, and the F-45 exemplifies this with its cutting-edge sensor fusion, long-range precision strike capabilities, and unparalleled electronic warfare systems. On the other side of the globe, China's ambitions materialize in the form of leaked images showcasing the highly classified J-28X Blackfire. Some experts say that Chinese design ideas are close to American ones, but China seems determined to break new ground and show that it is the leader in the sixth-generation field. The J-28X Blackfire is said to have advanced AI systems that let it handle huge amounts of data and make decisions in real time. Its sleek form and built-in weapons systems make people wonder if it can do more than just be an air superiority fighter. But what sets these fighters apart is not just the aircraft themselves, but also the approach to their entire fighter program. The U.S. boasts a vast network of allies, which enables it to share the development cost, while China, with its centralized and secretive development structure, can rapidly make decisions without facing the bureaucracy seen in democratic systems. The future battlefield is likely to be dynamic, and any fighter's capacity to upgrade and react fast will be vital to success. The United States has an advantage in this area due to its extensive experience with complex aviation projects, a responsive defense sector, and well-established supply chains. Meanwhile, China, despite fast progress, has yet to match the United States in combat aviation experience. As tensions grow and technological advances speed, we can only speculate. Will the United States keep its position as the apex of aerial combat, or will China's unrelenting determination to innovate and excel lead it to the throne of the skies? One thing is certain: The contest for sixth-generation domination is a clash of ideas, a race of strategic minds, and a test of nations' technical and technological prowess. The United States won't give up the lead in the race for sixth-generation success because it has a long history of coming up with new cutting-edge aviation technology. Enter the Next Generation Air Dominance (NGAD) program, an ambitious plan to make a fighter that not only meets, but also goes above and beyond the difficulties of the modern aerial battlefield. This new fighter is ready to give U.S. troops air superiority even in the most difficult and contested operational environments. The NGAD's breakthrough stealth capabilities are at the heart of its dominance. The fighter jet's revolutionary triangular form lowers its radar cross-section, making it extremely difficult for foes to identify and track. The usual vertical stabilizers have been removed, a dramatic departure from design rules that reduces the aircraft's radar signature even further. With these cutting-edge modifications, the NGAD achieves previously unthinkable levels of stealth, hovering unseen in the sky like a ravenous phantom. But that's not all. The NGAD program also uses new technologies that push the limits of aerial warfare. With improved sensor fusion, the plane can collect and handle a huge amount of data from a wide range of sources, both on board and outside the plane. This gives the pilot a complete picture of what's going on in the battle space, so he or she can make quick choices with confidence and accuracy. The fighter's avionics are nothing short of futuristic. The NGAD incorporates an artificial intelligence machine learning (AI/ML) system that interacts seamlessly with the pilot, providing real-time assistance in a way that elevates human-machine collaboration to a whole new level. This combination of human skill and technological prowess grants the pilot superhuman capabilities, outmaneuvering adversaries without problems. Moreover, the NGAD is not a one-size-fits-all solution. The program envisions a family of interconnected aircraft working in tandem. This method allows for adaptability in mission design and execution by providing distinct variations optimized for tasks like air-to-air combat, reconnaissance, electronic warfare, and others. When all of these planes are working in unison, they form a formidable network that can outsmart and destroy even the most formidable foes. As the NGAD program progresses, so do the challenges. Engineers, scientists, and the whole defense business are pushed to their limits and beyond by the need for unbeatable performance. Yet, this relentless pursuit of air dominance drives innovation, elevating the capabilities of the U.S. military to astonishing heights. The arrival of sixth-generation fighters is poised to transform global defense strategies. These cutting-edge planes have a devastating combination of speed, stealth, and artificial intelligence, making them formidable opponents who will compel nations to reconsider their approach to aerial combat. Traditional air defense systems, which have been the backbone of many countries' military strategies, might find themselves at a crossroads. The enhanced stealth capabilities of these new fighters could render existing radar systems less effective, leaving nations vulnerable to potential airborne threats. As a result, countries will need to invest heavily in upgrading their defense infrastructure and devising innovative tactics to counter these advanced airborne platforms. The liberty of sixth-generation fighters is one of the things that sets them apart. These planes can use artificial intelligence to make split-second decisions in battle, making them less reliant on human pilots and giving the battlefield a new feel. The ability of these fighters to work in groups and set up contact networks could lead to a change in aerial strategies, with a greater focus on network-centric warfare. With this method, military assets like drones, satellites, ground forces, and naval units would share and combine info in real time. This would make military operations more complete and well-coordinated. But there will be some problems with the wide use of sixth-generation weapons. To create and make such advanced technology, a lot of money needs to be spent, which could lead to changes in defense budgets. Larger, more highly advanced countries may have enough money to do these projects on their own. Smaller countries may have a hard time choosing whether to work with global partners on joint ventures or to buy cheaper platforms that still have some ability to defend against the threat posed by these advanced aircraft. Moreover, the introduction of sixth-generation fighters into the international arena may trigger geopolitical ripples. Allies of countries possessing this technology might benefit from its protection, while other nations may seek to form new alliances to balance the power shift. The strategic importance of air bases and airspace control could rise significantly, as these next-gen fighters can cover vast distances in remarkably short time frames. As the world eagerly waits for China to show off its top-secret supersonic sixth-generation fighter, it is important to think about what this means for military technology. In addition to their impressive abilities and cutting-edge features, the development and use of these next-generation fighters raise important environmental and social issues that need our attention. To begin with, there is an environmental cost to the superior performance of sixth-generation fighters. There is a direct correlation between the higher emissions of greenhouse gases and the increased fuel consumption of these high-speed, high-altitude aircraft. Nations must account for the environmental impact of their military aviation operations as the global climate catastrophe looms. Protecting the country's military is critical, but so is finding measures to lessen the impact these cutting-edge warplanes have on the environment. In response to these concerns, researchers and defense industries are actively exploring alternative propulsion technologies. From more fuel-efficient engines to hybrid electric systems, the aim is to reduce the environmental impact without compromising on performance. Moreover, operational practices and training protocols can be optimized to minimize fuel consumption during military exercises and routine flights. Striking a balance between safeguarding the planet and maintaining military readiness is a complex challenge that will require international collaboration and innovation. Beyond environmental considerations, the unprecedented lethality and autonomy of sixth-generation fighters bring ethical questions to the forefront. As artificial intelligence, AI systems play an increasingly decisive role in combat, the concept of ethical warfare takes on a whole new meaning. These advanced aircraft have the potential to operate with reduced human intervention, raising concerns about accountability and the potential for unintended consequences in the fog of war. Therefore, policymakers, military leaders, and experts must collaborate to develop effective regulations and frameworks governing the application of artificial intelligence to military operations. And so, the age of the sixth-generation fighter jets dawns, symbolizing not just the evolution of warfare, but the boundless human spirit that yearns to conquer not just the skies, but the challenges that lie ahead. It is in the embrace of knowledge, collaboration, and compassion that the true power of humanity lies.
AI is reshaping warfare, as seen with Northrop Grumman's Manta Ray submersible. Replacing humans with robots could save lives, but raises ethical concerns about control and accountability. While widespread deployment might revolutionize defense, questions remain. Is the world ready to entrust autonomous AI with decisions over nuclear weapons? How much of this robotic warfare will truly benefit humanity? Join us as we unveil how the new DARPA Manta submarine leaves rivals in the dust. As engineers have tackled challenges throughout history, Northrop Grumman has consistently developed a remarkable array of innovative ideas. This tradition can be traced to visionaries like Leonardo da Vinci, who designed bird-inspired flying machines. Following this legacy, Northrop Grumman has introduced the Manta Ray, a project that merges the hydrodynamic principles of its namesake fish with advanced autonomous systems and energy-efficient propulsion technology. Northrop Grumman's most recently finished prototype, the Manta Ray Uncrewed Underwater Vehicle, UUV, was unveiled earlier this year. Northrop Grumman developed the vehicle under contract from the Defense Advanced Research Projects Agency, DARPA. Hence, Manta Ray was the result from 4 years of work toward DARPA's project for developing an autonomous, extra-large uncrewed underwater vehicle, XLUUV, capable of doing long-range and long-duration missions without any human being around. DARPA's requirement poses a new approach that could enable an autonomous, extra-large, uncrewed underwater vehicle to cover vast distances for many months while using minimal energy. This needed speed requires a big boat that can be launched directly from a pier rather than from a ship or submarine. This requirement leads to a futuristic glider that is capable of carrying over long lengths of very large payloads, using a system drawn from glider-type propulsion, the manta ray. The manta ray alters its buoyancy to rise through the water, then glides downward, taking advantage of a hydrodynamically optimized hull. Recently, Northrop Grumman has completed the manta ray and moved it for testing in California from the production facility in Maryland, though within subsections. On that account, proving a streamlined way of shipping a system around the globe and assembling it, while also cutting down on the valuable pier space in naval installations. As Warner, a representative of Northrop Grumman, informed, bringing the vehicle to the area it operates in would have cost significant amounts of energy. In his words, transporting the vehicle first to where it needs to be installed and used saves energy that it will otherwise burn in moving transit. Similarly, Manta Ray has been designed for multi-role operations. It has several payload bays of different sizes and configurations, enabling the aircraft to carry out a range of naval missions, which are valuable for applications ranging from surveillance and reconnaissance to logistics and specialized undersea missions. However, the Manta Ray program inverts UUV's capabilities regarding operation without the demand for human logistics backing or on-deck maintenance at sea for extended periods of time. The Manta Ray initiative captured contract options with DARPA to advance the program. The project aimed to develop advanced technology for unmanned underwater vehicles capable of long-duration and long-range operations in ocean environments. There are three prime contractors: Northrop Grumman Systems Corporation, Martin Defense Group, LLC, formerly Navatech, LLC, and Metron Inc. The challenge was to focus on solving major technical issues such as energy management, increased vehicle reliability, biofouling and corrosion mitigation, accurate navigation, and collision avoidance with underwater obstacles. These areas of focus are crucial in extending the U.S. Navy's operational reach and effectiveness in underwater environments. In response, the program hit a major milestone earlier this year. Though preliminary design reviews were completed early in 2021, these anticipated reviews certified the viability and possible realization of initial designs aligned with program objectives. After that, selected performers moved forward in maturing their ideas through critical design review, an imperative step toward design maturity and readiness for the next phase, which is vehicle fabrication and testing. In the continuous ambitious effort to transform underwater operations, DARPA awarded Phase 2 contracts for the Manta Ray program in 2020. The program aims to develop advanced UUVs designed to conduct autonomous, long-duration missions with extended range travel within ocean environments. Each of the program's two prime contractors, Northrop Grumman Systems Corporation and Martin Defense Group, has its role in developing a unique full-scale demonstration vehicle to realize this vision. Martin was tasked with delivering a new tactically offensive autonomous vehicle. Whereas Northrop is modifying an existing program, both vehicles are built to acquire objectives or provide reconnaissance into an adversary's country. Martin has forged a new concept. However, the contracts are signed between their respective parent companies, Northrop Grumman Corporation and Martin Defense Group, LLC. Northrop Grumman Corporation manages the program Manta Ray. According to the scheduled phases in this ceremony, it was proud to announce the signing of contracts with small companies at this regular event. This long-term goal has led to the development of phases from the Manta Ray solicitation. It falls under DARPA's Undersea Warfare Programs Office on the management of Manta Ray solicitation and eventual contracts. Each contractor demonstrator must meet the following four requirements: a UUV for its autonomous missions, designed for an indeterminate duration over long distances, able to operate from multiple types of platform host bases, and functional in ocean environments. The Manta Ray program emphasizes autonomy and endurance, aiming to develop UUVs that can operate for extended periods without requiring on-site human logistics or maintenance. The first phase endeavored innovative technological solutions in the following core areas: energy management, extreme environment reliability, biofouling and corrosion control, navigation, and obstacle avoidance. These would be used to create underwater vehicles capable of sustaining missions in ocean's complex and dynamic environments. Again, by investing in various innovative techniques, DARPA can transfer pioneering underwater technologies to its national security partners. The Manta Ray program will play a pivotal role in this effort by introducing a new category of underwater vehicles and providing essential component technologies supporting other important underwater initiatives. The first phase ended with holding critical design reviews, demonstrating that the designs had matured and had completed preparations for the next phase. During Phase 2, the contractors were engaged in subsystem testing, building, and demonstration of fully integrated underwater vehicles. The demonstration thus far marked a significant step towards realizing UUVs with endurance and operational capabilities that were never fielded before, with transformational potential for naval and undersea mission applications. However, with its novel attributes to delivering groundbreaking technologies that create strategic surprises, the UUV is engineered to push the boundaries of undersea operations, focusing on versatility, autonomy, and logistical efficiency. It has been designed to be payload capable. It has an array of flexible payload bays to fly on various mission profiles, such as surveillance, reconnaissance, logistics, and other naval critical operations. Thus, it can be very flexible for various military applications. The manta ray is designed to conduct missions independent of human logistics on land, reducing traditional demand for logistical support from the basing. This makes it more useful for long-term missions in remote or contested areas that might not permit human presence or be too hazardous. Another unique capability of the manta ray is its ability to moor itself to the seafloor and then enter low-power hibernation. This action tremendously increases its endurance and allows it to save energy until needed, thus supporting long-term maintenance in the most difficult oceanic environments. It is modular in design and can thus be taken apart and shipped in 5 standard shipping containers. This offers an easy solution for transporting and facilitates quick assembly and launch into the field, allowing it to be used on expeditionary missions around the world without too much naval infrastructure. With such advanced design features, the manta ray is on the verge of really changing underwater vehicle capabilities. Its strategic flexibility, operational independence, and effective logistics make it a potential key asset for shaping new naval operations, not least because this vision closely matches DARPA's innovation and technology progress goals. However, the United States is not alone in trying to create underwater drones that can independently travel long distances with low fuel consumption. In January 2023, Russia announced and introduced a long-range underwater or submarine drone known as Poseidon. It looks much like a torpedo, but is powered by nuclear energy and capable of carrying a nuclear warhead. The expectation is that what DARPA and the US military want from manta ray will go beyond having any other building that doesn't use the fission nuclear energy source. In underwater vehicle design, there is a notable distinction between 2 types of vehicles: those optimized for endurance and those designed for carrying payloads. As Warner discussed in a 2022 podcast, vehicles that excel in long-duration missions typically sacrifice payload capacity and are limited in the mass and energy demands they can support. Conversely, a more traditional propeller-driven underwater vehicle is often necessary if a vehicle is needed to transport larger sensors or payloads or to accommodate devices with higher energy requirements. However, such vehicles generally do not offer the same level of endurance that military applications often require. The ocean is full of potential energy sources, such as currents, waves, and even subtle differences in water temperature or salt levels. But there's no single perfect source of ocean energy for DARPA's goals. Additionally, Kelly Rule, an engineer at Sandia National Laboratories, an advisor on the program, noted in a podcast that wave energy is a valuable resource, particularly for near-surface transport. Most wave energy is concentrated in these upper layers of the ocean. However, said Rule, wave energy becomes less sustainable resource-wise at greater depths. Rule also pointed out that current energy, especially through tidal systems, is very local. Tidal energy is harvested at particular geographic sites called tidal streets, hence the need to find specific places for resource harvest. However, compared to manta ray, the military's most common robots are small, flat robots mounted on miniature tank treads. The most common unmanned ground vehicles can tackle rough terrain and usually have a variety of sensors built in, including audio and video surveillance and chemical detection. The robots are versatile with different sensor or weapon packages available that mount to the main chassis. Virtually all of them are man-portable. The Talon is a man-portable robot operating on small treads. In its base configuration, it weighs less than 100 pounds, 45 kilograms. Talon is operated with a joystick control, has 7 speed settings, and has a top speed of 6 feet by 1.8 meters per second. It can use its treads to climb stairs, maneuver through rubble, and even take on snow. Versatility has also been designed into the Talon with multiple possible configurations that adapt the robot to the situation. The basic Talon includes audio and video listening devices and a mechanical arm. A lightweight version of 60 pounds or 27 kilograms omits the arm. Talons were used for search and rescue at WTC Ground Zero, and they have been used in Bosnia, Afghanistan, and Iraq for the disposal of live grenades, improvised explosive devices, and other dangerous explosives. Recently, the Talon was prepared to take on an even bigger role. All Talons are now equipped with chemical, gas, temperature, and radiation sensors. The military is even running tests on Talons that carry guns. According to manufacturer Foster Miller, Talon robots can be configured with M240 or M249 machine guns or Barrett 50 caliber rifles. The Packbot is another small robot that operates on treads. It's even smaller and lighter than the Talon, weighing about 40 pounds, which is 18 kilograms in the basic Scout configuration. The Packbot is man-portable and designed to fit into the U.S. Army's new standard pack, the Modular Lightweight Load-Carrying Equipment, MOLE. Controlled by a Pentium processor designed to withstand rough treatment, Packbot's chassis has a GPS, an electronic compass, and temperature sensors built in. Packbot manufacturer iRobot says Packbot can move more than 8 mph, 13 kph, be deployed in minutes, and withstand a 6-foot, 1.8 meter drop onto concrete, the equivalent of 400 kilograms of force. Also, the U.S. soldiers regularly take advantage of this ruggedness, tossing Packbot through windows of hostile buildings, and then using it to find out where enemies are hiding. Even if Packbot lands upside down, it can right itself using powerful treaded flippers, which also help it climb obstacles. Another is Matilda, which stands for Mesa Associates Tactical Integrated Light Force Deployment Assembly. Mesa Robotics made it, and it is similar to other small robot designs, but has a higher profile due to its triangular tread shape. It weighs 61 pounds and weighs 28 kilograms with batteries, can be carried by 1 or 2 people, and fits in the trunk of a car. Matilda has numerous possible configurations. For instance, it can be equipped with a mechanical arm, or various cameras and sensors, and even tow a small trailer. The robot's top speed is 3 feet, 1 meter per second, and its single charge runtime is 4 to 6 hours. In the event of tread damage, the quick change tracks can be swapped in about 5 minutes. The Mule and ARV vehicles might begin a new kind of warfare. There are 3 proposed versions of the Mule, all of which will roll around on wheels. 2 variants, a vehicle that could carry more than a ton of equipment and designed to detect and turn off anti-tank landmines, are similar to current military robots. The 3rd variation is an armed robotic vehicle assault light ARV-AL device. It will have reconnaissance, surveillance, target acquisition, and RSTA, as well as package and integrated weapons. In other words, this robot is similar to a human soldier who can engage the enemy in combat. ARV robots are less like soldiers and more like tanks. The Army intends to use ARVA robots to support manned vehicle missions. A tank squadron commander could use ARVA robots to extend his team's area of influence without the need for more soldiers. The robots could take the most dangerous positions and provide support whenever the manned vehicles enter a combat situation. However, one major concern for the military and engineers is the chance that a robot malfunctions. Discussions about using armed robots often include the possibility of a robot firing on friendly forces or innocent bystanders. It might seem paranoid, but malfunctioning robots have caused scares. In 1993, a bomb squad robot in San Francisco malfunctioned while on a mission to disable a bomb. The robot began to spin uncontrollably just before it could grasp the explosive device. Fortunately, the robot didn't cause the device to detonate. Military officials say that the goal of using unmanned vehicles and robots is to engage in combat without risking human casualties, or at least human casualties on our side. Another benefit is that even though robots are expensive, they may be cheaper than fielding human soldiers. Robots require maintenance but don't need health or retirement benefits. They might also be able to serve longer terms than human soldiers could. Many believe robots will never completely replace human soldiers, but will be used in dangerous or tedious missions. A robot soldier will never be bored, so it's ideal for guard duty or long-term surveillance missions. South Korea plans to use robots to patrol its border with North Korea. The robots are called intelligent surveillance and guard robots, and they use regular and infrared cameras to detect intruders up to 2.5 miles away. The robots can pursue a target, demanding a coded access number once they're within 10 meters of the intruder. The robot could sound an alarm or fire a weapon at the intruder if the target can't give the correct code. Currently, there are robots on the market that can carry and fire weapons like shotguns, pepper spray, grenade launchers, or even Hellfire missiles. The Mule Arvuz AL robot can fire a line-of-sight gun and anti-tank weaponry. Remote-controlled Talon robots can carry everything from an M240 machine gun to a 50 caliber rifle to grenades and rocket launchers. The South Korean patrol robot can either fire non-lethal rubber bullets at intruders or carry a K3 machine gun, a light machine gun similar to the M249. The U.S. Marine Corps Gladiator Tactical Unmanned Ground Vehicle, 2GV, can also carry an arsenal of lethal and non-lethal weapons, including shoulder-launched, multi-purpose assault weapons, small, designed to destroy bunkers, disable armored vehicles, and break through fortifications, M240 or M249 machine guns. Light Vehicle Obscurant Smoke System, LVOS, a device that launches smoke grenades. Similarly, the Anti-Personnel Obstacle Breaching System, APOBS, a rocket that tows a line connected to fragmentation grenades, is designed to destroy obstacles like landmines. A large, heavy robot could handle weapons that are too cumbersome, dangerous, or powerful for humans. The ARVA could carry a medium-caliber cannon, a missile, and a heavy machine gun system. The Army intends to primarily use robots like the ARVA to support manned vehicles, so the armament must be comparable to a tank's. Other tools will include sensors and cameras, allowing the robots to perceive and navigate various hazardous environments. Robots like the Gladiator will have thermal imaging cameras, devices that detect heat and produce images that humans can see. Most robots will also have normal video cameras. A major goal of the DARPA project is to create a universal platform that the Army and other forces can incorporate into military systems from now on. One of the challenges the military has faced over the years is that it relies on a mix of equipment, vehicles, and software that aren't integrated, making battle coordination and tactical discussions difficult. Ideally, all military robots will share a common platform, allowing officers to rely on multiple robots in a complex mission. For example, Manta Ray could keep an area under surveillance, broadcasting information to unmanned ground vehicles as they enter. Once again, the United States has shocked the world with a mind-blowing technology, the X-Wing aircraft. This invention is renowned for its groundbreaking design and unparalleled capabilities, and has redefined aerial combat in ways that few could have imagined. But what is it about this fighter that makes it so exceptional? How did it revolutionize the way air battles are fought and won? Join us as we look at the features that set the X-Wing apart as a true game-changer in modern warfare. The X-plane, also known as the X-65, is in a position to make truly revolutionary changes in the field of air transportation. This experimental aircraft comes from DARPA's Control of Revolutionary Aircraft with New Effectors known as CRANE program. Aurora Flight Sciences, a Boeing-owned company, has started production after successfully completing a crucial step called the Critical Design Review, which approved moving forward with building the aircraft. The main task of the X-65 is to validate an innovative idea known as active flow control. This technology relies on steering the aircraft and improving its performance without moving parts, such as flaps or rudders. Instead, the system applies pressurized air delivered by 14 effectors, each individually adapted to specific locations on the wings and surrounding surfaces. Using this novel configuration, the plane can be more agile and perform well across a wide range of speeds and flight conditions. Perhaps one of the most interesting aspects of the X-65 is its modularity. The wings are replaceable, and the active flow control effectors can be swapped with alternative designs. This versatility transforms the plane into a flying test bed, serving as a platform for continuous research and development into the next generation of aviation technology. Active flow control technology holds enormous promise. By eliminating the need for traditional mechanical parts, planes could become lighter, more efficient, and easier to maintain. These enhancements could be applied to both military and commercial aviation. Aurora Flight Sciences has begun fabrication on the 30-foot wingspan, uncrewed X-65 at its West Virginia and Mississippi plants. Final assembly and system testing will take place at its headquarters in Manassas, Virginia. Kevin Ulick, the Crane Program Director at Aurora Flight Sciences, expressed excitement about entering the manufacturing phase. He emphasized the team's progress toward validating active flow control technology and unlocking new possibilities in the development of future aircraft designs. He also noted that Aurora was honored to contribute to such a transformative program. The X-65 project represents years of effort. Over the past 3 years, Aurora and Boeing have been working on everything from early design concepts to wind tunnel testing and trials of the active flow control system. The ultimate objective is to conduct flight tests of the 7,000-pound aircraft by the summer of 2025, during which it is expected to reach speeds of up to Mach 0.7, or approximately 535 miles per hour. These tests are anticipated to demonstrate how active flow control can enhance not only flight performance, but also the design and construction of aircraft. The U.S. X-plane concept aims to redefine amphibious warfare. A groundbreaking airborne boat is currently under development that could dramatically change the way amphibious warfare is carried out. This exciting project, the Liberty Lifter, is being designed under the Defense Advanced Research Projects Agency, DARPA. The goal is to create a large, long-range aircraft capable of flying close to the surface of the water, allowing it to perform heavy lifting while staying under the radar. This new class of aircraft is being developed to support island missile launches and back amphibious military deployments. Flying at low levels above the water's surface generates the ground effect, which lowers air resistance, improves fuel economy, and makes the aircraft harder to detect by radar. The water surface introduces radar clutter, making it extremely difficult for enemy missile systems to locate the aircraft. Upon completion, the Liberty Lifter is predicted to fly at an altitude of 3,000 meters, travel up to 7,400 kilometers, and carry payloads of up to 90 tons at speeds of up to 460 kilometers per hour using the ground effect. Ramp access and egress will be achieved via ramps in the nose or tail of the aircraft. Currently, the Department of Defense has contracted General Atomics and Aurora Flight Sciences to conceptualize this new type of aerial vehicle for DARPA. The design from General Atomics features 12 turboshaft engines and a twin-hull mid-wing structure. In contrast, Aurora Flight Sciences is using a conventional single-hull flying boat configuration with a high wing and 8 turboprop engines for propulsion. The U.S. government has allocated $55 million for this conceptual phase, with plans to choose one design by 2026. Flight tests are expected to start in late 2027, and the aircraft could be fully operational and in military service by 2028. This is not the first time the U.S. has considered seaplanes for military purposes. During World War II, seaplanes played a significant role, but became less popular after the war as helicopters and long-range fixed-wing aircraft took over many of their roles. Additionally, the U.S. developed a robust network of airstrips on Pacific islands, reducing the need for seaplanes. Nevertheless, recent developments in missile technology introduced by countries such as China and North Korea have prompted the U.S. to review its strategy. To prevent its entire arsenal from being concentrated on a few vulnerable locations, the U.S. has dispersed its assets over numerous small islands. These island outposts equipped with missile launchers form what is called a missile wall, designed to deter potential threats from China. However, ensuring these remote bases are stocked with ammunition and other supplies is difficult because most do not have airstrips, and small helicopters do not have the capacity to transport large amounts of cargo over long distances. This is where the Liberty Lifter could come in. Unlike traditional transport planes or helicopters, a seaplane like the Liberty Lifter can land on water, making it perfect for resupplying islands that lack runways. It offers a unique solution to a long-standing problem: how to maintain constant supplies for isolated military bases while keeping them protected from enemy attacks. The Liberty Lifter can address a significant issue in amphibious operations, particularly in the ship-to-shore phase, where troops and supplies are exposed to enemy fire. If destroyed, it can prevent attackers from seizing a strong position, allowing defending forces to counterattack. By using the Liberty Lifter, the U.S. military may be able to avoid some of these difficulties. In a direct delivery flight, the aircraft could provide heavy equipment and landing capabilities directly to the shore or the battlefield itself, minimizing the time and risk of conventional amphibious landings. This would make it more difficult for defenders to prevent an attack before it's too late. In the meantime, the U.S. military is employing makeshift solutions to address these issues. For example, in 2021, the U.S. Special Operations Command (SOC) created expendable floats for its MC-130J Commando II transport aircraft. These float capabilities make the aircraft amphibious, allowing them to launch and land on water. As a result, they are used as improvised seaplanes for special forces delivery and retrieval. Although these new generation solutions are useful, they are temporary measures compared to the function of a specially designed aircraft like the Liberty Lifter. The U.S. military is using makeshift solutions like expendable floats for its MC-130J Commando II transport aircraft to make them amphibious, allowing them to land on water for special forces delivery and retrieval. However, these temporary measures are temporary compared to specially designed aircraft like the Liberty Lifter. Advancements in weapons technology have made traditional amphibious landings more costly and difficult. The idea of OTH amphibious operations isn't new. With respect to June 1991, Jerome Beerley and Thomas Seal, both authors then with the U.S. Marine Corps Association, published an article on the nature in which OTH operations can alter military doctrine for undertaking amphibious assaults. In contrast to conventional amphibious landings, where they are necessary for troops to already secure a beachhead before their advance, OTH operations require troops to arrive quickly on the beach, organize them, and move them deep into enemy territory. This means that it is no longer necessary to establish a defensible beachhead or stockpile vast amounts of equipment on the beach, both of which are major targets if the enemy has success. It puts out of kilter all such operations and accelerates the entire process. The Liberty Lifter, with its ability to deliver heavy cargo and forces quickly while staying off the radar, could play a crucial role in supporting these types of OTH amphibious operations. The U.S. Marine Corps already employs a number of assets for amphibious landings such as hovercraft, amphibious assault vehicles, and helicopters. However, each of these has its limitations. However, the Liberty Lifter may be valuable as a complement to such current tools to provide an alternative means of importing troops and equipment into enemy ground without unnecessary risk to these units. For instance, in a 2020 study on behalf of the U.S. Marine Corps University, Stephen Yaden reviewed the advantages and disadvantages of multiple amphibious assault vehicles. Hovercrafts, though high speed and able to carry large amounts of equipment, are very delicate and lack the firepower and armor to effectively assault even well-fortified beachheads. In contrast, amphibious assault vehicles are armed and armored, and thus better suited for opposed landings, but do not have the range or speed for OTH. Because these types of vehicles are also susceptible to anti-tank weapons and lack the firepower to make up for the anti-tank element, they are risky to operate. Yaden further pointed out the need for air supremacy in amphibious landings. However, this is not always guaranteed. In some cases, anti-aircraft weapons can limit or prevent the use of aircraft, which is a significant disadvantage when trying to establish dominance on the battlefield. Due to these constraints, the Liberty Lifter can be a solution of great value by adding another dimension to the Marine Corps' amphibious operations. With its ability to carry heavy cargo, travel long distances, and avoid detection by enemy radar, the Liberty Lifter could help make amphibious assaults safer and more effective. It may offer a faster, more secure means of moving and deploying troops and equipment, supplementing the capabilities of hovercrafts, assault vehicles, and helicopters, and at least mitigating some of their limitations. In this fashion, the Liberty Lifter may have a critical role to play in modernizing AF and thereby lowering the risks and costs of such operations. A research subsidiary of Boeing, Aurora Flight Sciences, Aerospace and Aeronautics Research, focused on aviation, has revealed it is developing a next-generation X-plane with fan and wing technology. This new design aims to enable high-speed mobility in contested environments while functioning independently of runways, making it ideal for operations in locations without prepared landing areas. The X-plane is part of the U.S. government's Defense Advanced Research Projects Agency, DARPA Speed, and Runway Independent Technology Sprint program, which is focused on developing technologies that allow aircraft to achieve both high speeds and the ability to operate without relying on traditional runways. At the beginning of the year, DARPA made a contract award to Aurora and Bell for the Sprint program, an important move towards the realization of more flexible and effective military aircraft. The objective of the Sprint program is to develop, build, and fly an X-plane, which will showcase fundamental technologies and integrated systems required to build an air vehicle, simultaneously offering both high-speed and runway unawareness capabilities. Aurora, in partnership with Boeing, is developing and testing these technologies with the goal of supporting mobility needs in the U.S. military, particularly in difficult or hostile environments. Aurora has also released some renderings of the fan and wing technology, for which it is a core technology of the new X-plane. The fan and wing technology incorporates a three-dimensional lift fan within a combined wing body layout and enables vertical lift functions without compromising the aircraft's load capacity or the aerodynamic performance found in classic fixed-wing aircraft. This suite of characteristics is predicted to make the X-plane very versatile and powerful for use across a broad range of military applications. Currently, Aurora's Sprint program design, only an uncrewed aerial demonstrator with a wingspan of 45 foot long and a payload capacity of 1,000 lbs. This is only the beginning, as Aurora plans to expand this technology to larger and medium and heavy-lift aircraft for the future. They further predict a manned wing, 130 feet wide, with 4 fans and a 40-foot bay for paying load. This larger airborne platform has the potential to match or outperform in terms of payload, range, and speed current fixed-wing military transport aircraft while preserving the benefits of vertical takeoff and landing VTOL. This year, Aurora took a big step in demonstrating the feasibility of fan and wing technology. They finished the first of a battery of significant tests during the Sprint program. One of the major tests was a ground effect trial, which used a small 4.6-foot wingspan model with 3 lift fans. The outcome of the present test was that the suck-down effect of the lift fans, which may influence the aircraft in hover, is negligible. Also, the landing gear was positioned at the appropriate height in order to prevent any stability problem during ground operation, like gratuitous pitching moment. Looking ahead, Aurora plans to conduct more tests in late 2024 and early 2025, including wind tunnel tests and stability and control assessments using a larger 9-foot full wingspan aircraft model. These tests will help to further refine the aerodynamic design of the aircraft. The company also plans to begin flight tests in 2027, with the current phase of the Sprint program scheduled to continue until May 2025. The preliminary design review is set for April 2025. Mike Kaimona, president and CEO of Aurora, highlighted the potential effects of the Sprint program and noted that high-speed, quiet, and runway-free transportation capabilities being designed may have a powerful impact on safety and effectiveness of the military in contested areas. By making it possible for the U.S. military to operate in locations where traditional runways are not available, this technology could ensure that no area is off-limits for military operations. In general, the fan and wing X-plane development is a promising next generation in military aviation, providing humanitarian value in highly dynamic, high-speed, versatile transport in rough and hostile regimes. With the technology continually advancing, it is likely to make a significant difference to the way in which the U.S. military will conduct warfare around the globe. The X-wing is one of the most famous ships in the galaxy due to its unique S-foils and angular, sharp needle-nose cockpit. It's such a pervasive presence that it has altered the way we think about time itself. Or so it seemed after it became adopted as a symbol of hope when the Rebel Alliance attacked the Empire's Death Star. The gallantry and self-sacrifice of the Rebel pilots, not least Luke Skywalker piloting his iconic red-striped X-wing with the name Red 5, was a decisive event that shifted the calendar to zero BBY. Although Luke Skywalker is the most well-known pilot to fly the X-wing, many smaller pilots as well, such as Wedge Antilles, Tycho Selchuk, Corran Horn, Gavin Darklighter, and Poe Dameron, have also led this iconic starship. The X-wing was the heart and soul of the Rebel Alliance and the Resistance, resisting the tightening grip of the Galactic Empire, and eventually the First Order. But what might surprise some people is that the X-wing, with its famed design and capabilities, wasn't always meant to be the small but powerful fighter we know today. Indeed, it may well have become one of the Empire's most potent weapons, perhaps surpassing even the Great Death Star. Brilliant engineering currently drives the development of miracles in war conditions. And when the Clone Wars broke out between the Galactic Republic and the Separatists in 22 BBY, the Republic found itself in desperate need of a new starfighter. The Republic turned to the Incom Corporation and Sub-Pro Corporation to develop a ship strong enough to stand up to the Separatists' brutal firepower, in particular against the Vulture-class droid starfighters. All the Republic needed was an aircraft that was like the Vulture in terms of maneuverability and firepower, but also capable of fulfilling the aircraft's role both in space and on planets. The outcome was the Z-95 Headhunter, a fighter aircraft that was similar in an early stage of the X-Wing design, but with the familiar absent split wings. The Z-95 had two stationary wings that could cut through both space and atmosphere, along with Incom's 2A fission engines. It didn't come with a hyperdrive out of the box, and many models couldn't make hyperspace jumps, although they could be modified with parts from aftermarket suppliers. The Headhunter was still a powerful weaponized platform, equipped with blaster cannons, ion cannons, concussion missile launchers, and deflector shields, providing a credible combat asset in space combat. The Z-95 was particularly well-suited to the Reaper Squadron, and post-rise of the Empire, it saw use by the Rebel Alliance and even pirate factions. The Z-95 was a powerful fighter that influenced subsequent designs, including the ARC-170 starfighter. It featured a hyperdrive astromech socket and a X-shape for engine cooling. The ARC-170 was powerful during the Clone Wars, playing a significant role in major conflicts like the Battle of Sulust and the Battle of Malastari. However, its large size and massive guns made it difficult for stealth operations. Despite its limitations, the ARC-170 played a significant role in the Clone Wars, but was phased out as the Empire grew. The lessons from the Z-95 and ARC-170 helped create the T-65 X-Wing, the symbol of the Rebel Alliance. Thanks for watching. While you are still here, click on the link appearing on your screen to check out another of our videos. See you there.